Question number 11. Okay. Under what conditions of pressure and temperature does a real gas approximate to ideal gas? What is an ideal gas? Ideal gas obeys the postulates of the kinetic theory of gases. What is the postulate? The first postulate, one of the postulates tells you that the size of the molecules of a gas is negligible as compared to volume of the gas, which means that the density of these molecules are lower. Density is lower, right? This is one of the postulates which tells you. And secondly, it also says that no intermolecular forces are acting. Okay, no intermolecular forces act, okay, on the molecules of the gas. These are two postulates. So here also, when does it happen? Which means that when you say no intermolecular forces are acting, it means the molecules are not sticking like this. Okay, if it sticks like this, what will happen? The volume will increase. Volume of the molecule increases, or the mass of the molecules will increase, and density will increase. So it says that here also it mentions very clearly that density is low. So we need to look at this parameter. Okay, where do we have density is low? Now let us use the equation PV is equal to nRT. Okay, in this, what is n here? Number of moles, which I can write this as mass of the gas divided by molecular mass multiplied by R into TO. Here R, I will write this P is equal to R divided by M. I will take this constant. R is gas constant, M is the molecular mass, which is also a constant for a given gas. Okay, and then what do we have? This V comes downwards. This is small m divided by volume multiplied by T. I am taking some more time to explain this anyway. So R by capital M divided by density into temperature I get. In other words, now I can now write density is equal to this is P into M by R when this goes that side divided by T. Okay, this is what I have. Thus you see density is proportional to pressure and density is inversely proportional to temperature. If density has to be low, now what should be low? Pressure should be low, because you see, so pressure has to be low. Now let me write it down here. If I want something to be lower, if I want this gas to be an ideal gas, then what do we need? The density should be lower over here. And when will density be lower? Density will be lower when pressure becomes lower and temperature becomes higher from this equation, right? Because M and R is constant. Now let us look at the condition here. Pressure is lower and temperature is higher. Pressure is lower and temperature is higher corresponds to option C.